we're talking about special segments in triangles. I'm going to go ahead and put a triangle on the board here, and we will be able to take a look at some of the special segments that we have here. So, just go ahead and draw a triangle, any triangle you want to, just as long as it is a triangle. Remember, your paper is not taped to the desk. You can move it however you want to. So, now what we're going to create is something called a median. And a median is a segment that goes from a vertex to the midpoint of the opposite side. So we need to find some midpoints, 3 of them to be exact. So I'm going to use a compass. You can fold the paper, you can do whatever you need to do to find your midpoint. But I'm just going to do this really quick. Open this up past the halfway mark. There would be for 1. There's for the second one. And here's for the third one. Alright, so I'll take my straight edge again and line it up and find my midpoint. I'll call that M1. I'll line this one up. And I'll call this one M2. I'll line this one up. And I will call this one M3. So, in order to draw the median, we are going to draw a line from an angle, the vertex of an angle, to the opposite midpoint. So, here's a median. A M1 is a median. The segment A M1. This is point B. B M2 is a median. And if this is point C, excuse me, that's M3, not M2. We'll go C to M2. So C to M2, and we're able to create the medians. Now, what do we see? What's something special that happens? Give you a hint. It happens right there. All 3 medians intersect at a point. So, 3 lines intersect at one point. The lines, or the segments, are what we call concurrent. And the point of concurrency is called the centroid. So this point right here is called a centroid. And in another one, we'll talk a little bit more about what the actual centroid is.